Welcome to the physics class, BSc Physics, 3rd semester. Paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, Unit 3, Theory of Dielectrics and Moving Coil Galvanometer. Second session, we learnt about gas law in dielectric medium. Before going to the gas law, first we see knowing about electric flux. Electric flux means if a conductor, I am considering one conductor, electric field will be flowing through this conductor. Number of electric lines of force will be obtained around this conductor. So, number of lines, electric lines per unit volume is called as an electric flux. So, now we see the statement of the Gauss law. So, Gauss law states that flux in an electric field through a closed surface, through any closed surface, that is the surface integral of the E dot ds over a surface is equals to the 1 by epsilon naught times the total charge enclosed by the surface. If the surface does not enclose, the flux E equal to 0. Thus we can be write as an integral multiple of E into ds, which is equals to Q dividing by epsilon naught, Q inside of the surface. Inside of the surface, number of electric lines of force will be obtained. In case outside of the surface, this product of integral of E dot ds, which is equals to 0. This is the statement of Gauss law. Now we sing about Gauss law in case of dielectric medium. So, Gauss law in the presence of dielectric medium is given by surface integral of the E dot ds, which is equals to Q dividing by K into epsilon naught. Here, E is the applied electric field, D is the change in surface area, Q is the charge of the particle, epsilon naught is the permittivity, and K is a dielectric constant. So, in this case, the flux over an electric field through an E, any closed surface equals to 1 by epsilon naught times of the total charge enclosed by the surface, where epsilon naught is the absolute permittivity and K is a dielectric constant. Proof of this law is, so first we considering as an parallel plate capacitor with an area A. So, parallel plate capacitor means two plates will be obtained. In this case, between these two plates, air is in the medium. So, let plus Q and minus Q be the charges on the plates. Plus Q and minus Q be the E naught is the applied uniform electric field between the plates. E naught it obtained in the forward direction be the uniform electric field between the plates. So, let PQRS will be obtained by the Gaussian surface of the material. Next, so from Gauss law, we writing about the statement of integral multiple of the electric flux over a into ds, which is equals to Q divided by epsilon naught. So, in this case, E naught into A is the surface area, which is equals to Q divided by epsilon naught. This equation becomes E naught equals Q divided by epsilon naught into A. This we call it as an equation 1. Now suppose a dielectric material of a dielectric constant K is introduced between the plates. Dielectric slab gets polarized. So now we seen that the two parallel plates in between dielectric medium will be introduced. This will be get dipole moment of the molecules will be takes place. Then this means dielectric slab gets polarized. So in this case, negative charge minus Q dash induced on the surface of the positive plate side, and equal positive charge of plus Q dash will be induced on the other surface. So These induced charges produces own electric field, that is E naught. E naught will be obtained. This E naught, it is in the direction opposite to the electric field. So E naught will be, E will be applied. Applied electric field is in the forward direction. So E naught will be obtained, or E dash in this opposite direction. So net charge of the net charge within the Gaussian surface will be changes from plus q dash to the minus q dash, plus q to the minus q dash, that is represented by net charge will be plus q plus minus q dash. So it is simplification by plus q, plus into minus becomes minus q dash. From the Gauss law, integral multiple of the flux of electric field and the surface change in surface, which is equals to the change in charge, that is q minus q dash dividing by epsilon naught. So which is equals to a E into the integral multiple of the change in surface, which will be equals to an area A, which is equals to q minus q dash divided by epsilon naught. This becomes A will be comes to the equation right side. This becomes denominator term. We will get electric field E is equals to q minus q dash dividing by epsilon naught into A. This we call it as an equation 2. Also dielectric constant we know about, K is equals to E naught dividing by E. So E naught is equals to K into A. Next, substitute this value in equation 1. We get K into E, which is equals to Q dividing by epsilon naught into A. So from the Gauss law term, it will be obtained from the Gauss law. Gauss law term. This term. So it becomes next kinetic energy K into E is equals to Q dividing by epsilon naught into A. This becomes we want the value of applied electric field E is equals to Q dividing by K into epsilon naught into A. So equating the equations from 2 and 3. So both the left hand side E and E. Then equating the right hand sides, we will get Q minus Q dash dividing by epsilon naught into A, which is equals to Q dividing by K into epsilon naught into A. So we want, in this case, denominator term epsilon naught into A will get cancelled. Finally we will get Q minus Q dash is equals to Q dividing by K. Next, this value substitute into the Gauss law, we will get integral multiple of the flux of electric field into the surface, which is equals to the Q dividing by K into epsilon naught. This is known as in Gauss law in the presence of the dielectric. Gauss law in the presence of the dielectric. So thank you for watching this second session.